Hi guys, got a late start tonight because I was trying to get my Algebra 1 video done and that took quite a while. I've got everything worked out. We're just going to go through and record the audio real quick and then we'll get it all posted. Okay? On this practice, we had one side that was form G, one side was form K. I did the problems on the form G side of the homework. Okay. Let's get started with it. Okay, first we drew out our graphs. Okay, get those written all down here really quickly. See if I can speed that up a little bit. And then we drew out the graphs for each one. Get that drawn out real quick. Alright, there we go. Slow this down a little bit. Now, this said to use the vertical line test to determine whether each graph represents a function. I asked you to use more than one line, okay, to help determine at different points through the graph. Okay, so on number 6, I drew 3 lines. We can see that each line crosses the graph only one time. Okay, therefore, yes, this is a function. Number 7. We draw 3 lines. Okay, there we go. Now, we can see that it crosses, the first line I drew crossed in one spot. The second line I drew crossed in 2 spots. The third line I drew actually crossed in 3 points. Okay? Because it's crossed in more than one point at any given vertical line test, no, this is not a function. Okay? Number 8. Go a little bit faster. Draw my 3 lines. Each one crossed the graph just one time. So yes, this was a function. Alright, we're going to go to number 15. Okay, let's speed this along a little bit here. Okay, use set notation to write the domain and range of the function. Okay, they gave us an equation. 15 said y was equal to 3x minus 11. If we graph this out, okay, we will see that this is the graph of a line. Okay. Now, we can see as the line goes up and out, and I forgot to draw my arrows in there, just pretend there's arrows on the end of that. My domain is the left and right movement of this graph, and that continues forever in both directions. So because of that, and because I have a line drawn between all my points, my domain is all real numbers. So we write that in set notation, starting with a brace. Back that up just a smidge there so I can. Okay, starting with a brace, we say x and then a colon for such that x is equal to the double bar r for all real numbers. And finish with a brace. Now my range is all the vertical movement up and down. Okay, and that line goes on forever in both directions, up and down. Okay, remember that range is our y value, so when we're writing that in set notation, we will use the y instead of the x. So range is brace. Y is such that y is also equal to all real numbers. All your linear equations will always have a domain and range that are both all real numbers. Okay? Alright, that's it for that one. Okay, that was writing in set notation. The next one, we're going to write in interval notation. Let me get all this written out, and then I'll pause it and read it to you. Okay. Bananas are on sale for $1.19 a pound with a limit of 5 pounds per customer. The function S of X is equal to $1.19 times X, where X is the weight of the bananas in pounds and S of X is the sale price in dollars. Okay, so let's talk about the domain. We're looking for X, which is the pounds, and we have a limit of 5 pounds per customer. Okay, you can choose to not buy bananas, so that is a lower limit of 0, with an upper limit of all that they will allow you to buy at the sale price, which is 5 pounds. Okay, it includes 0 pounds, so we use the square brace, square bracket, and it includes 5 pounds, a full 5 pounds, so it includes the 5, so we use the square bracket on that side as well. Now, for our range, okay, my range is S of X. It is the sale price in dollars. Okay, the equation is that 1.19 times X. Okay, my lower limit, okay, the amount that I spend when I buy 0 pounds is $0. Okay, then the amount I spend when I buy 5 pounds is $5.95. Okay, again, 0 is included in that, so it's a square bracket, and $5.95 is included in that, so that is also a square bracket. Okay, all right. Number 17, we have a graph. Let me go ahead and speed those graphs up real quick. Okay. Let's get that all erased there. Okay. Now, we are going to be finding the domain and the range of each relation, and we are going to determine whether or not it is a function. Okay, so over here on the left, we have that's an absolute value graph. Okay, the domain going left and right, we can see by the arrows, it continues to go both left and right forever. So that gives us a domain of all real numbers. Okay, now my range starts right here and goes up forever. Okay, now that tells me that I'm going to start my graph at the -1, There it goes. It's finally starting to write. I'm going to start my graph at -1 and go for through infinity. So we're going to say that y is such that y is greater than or equal to -1. Okay? That's number 17. Number 18. Okay, my domain starts at 0 and ends at 2. Okay? So, I'm going to get my brace up there. X is such that. Okay. 0 is the low side of this. So 0 is my least number. Okay? Then we're going to say that 0 is less than or equal to x, and x is less than or equal to +2. Okay? Because it ends at 2. Okay, my range starts at -2. My graph ends at +2. This is our range. Okay, it's the y. So we're going to put our swirly brace and say y is such that y. Okay, y is such that. Now the graph starts at -2 at the bottom. So we're going to start our inequality with -2. Okay. Then it goes from -2 up. So -2 will be less than or equal to the y. And then y will be less than or equal to 2 because our graph stops at 2. Okay. All right. Next problem. Alright, number 19. I'm going to get this to write it all out real quickly. And then I'll read it off to you. Okay. Okay, it says the surface area of a sphere is a function of the radius of the sphere. So A is equal to 4 times pi times radius squared. It wants us to evaluate the function for a basketball with a radius of 11.5 centimeters. Okay, so we have our function. Area is equal to 4 pi r squared, and the radius is 11.5 centimeters. Okay, we're going to substitute that 11.5 for r. Okay, we're going to plug that into our handy dandy calculator, and we come out with 1,661.903 centimeters squared. And that's all there is for that one. Alright. Number 20. I'm going to read this off real quick, and then we're going to write some things down. Okay? The relation between the length of the femur, F, that's the bone from the knee to the hip joint, and the height of an adult woman, H, is modeled by the function h of f is equal to 2.3 times f plus 24. In the following ordered pairs, the first coordinate is the femur length, and the second coordinate is the corresponding height in inches. It wants us to find the unknown measure in each ordered pair. Okay? So, we have the femur is F, the height of a woman, an adult woman, is H. We said h of f is 2.3F plus 24. Our ordered pair is the femur and the height, and it wants us to find the unknown. Okay. Part A gives us an ordered pair of 13T. So we're going to substitute 13 in for F for the femur length. Okay. So 2.3 times 13 plus 24. Okay, 2.3 times 13 is 29.9 plus 24. So T is equal to 53.9. Okay, B gives us a coordinate pair of 14.5P. Okay, substitute 14.5 for the femur length. So we get 2.3 times 14.5 plus 24. 2.3 times 14.5 is 33.35 plus 24 gives us a height P equal to 57.35. For C, this time they give us the height and we need to find the femur length. So my height is 56.2. Okay, is equal to 2.3M plus 24. I'm going to subtract 24 from both sides. I get 32.2 is equal to 2.3M. I divide by 2.3 to get M by itself. And M is equal to 14. For D, we have N and 72.3. 72.3 is our height, is equal to 2.3N plus 24. I'm going to subtract 24 from both sides. Okay, that gives me 48.3 is equal to 2.3N. Divide both sides by 2.3. And N is equal to 21. All right. That is all for Form G of the homework. Check yourself on those, and then that should help you out with the remainder, the last 4 to 6 that you have on your homework. Okay? Y'all have a good night. We'll see you tomorrow.